welcome back to part 2 of our square root action. And now I've got a fun one for you. This one has a little more pizzazz in it. What if I ask you to multiply the square root of 18 times the square root of 24? Well, you can multiply those together right now. But let's face it, if we take 18 times 24, we're going to have a pretty good sized number. And breaking down big square roots just really isn't a whole lot of fun. So it's generally easier if you break the roots down first and then multiply them. You'll keep your numbers a lot smaller. So what would break down 18? Well, we just did it on that previous problem, so we should be on top of that one. 18 is 9 times 2. Square root of 9 is really 3. So I really have square root 3 times the square root of 2. All right, what breaks 24 down? Be sure you get a number that's a perfect square. Because a lot of people will look at it and go, 8 times 3. Well, neither 8 nor 3 is a perfect square number, so we don't want that one. Instead, we actually need to use 4 times 6, because 4 is a perfect square. And of course, square root of 4 is really 2, so we would have 2 times the square root of 6. Now, when you multiply them together, you're multiplying much smaller numbers, and it's a whole lot easier. So if you take the coefficients times each other, 3 times 2 is going to give me 6. Multiplying the roots, square root of 2 times square root of 6 is really square root of 12. That works fine, other than you have to stop and ask yourself, is that in simplest form? Can I break it down any farther? And in this instance, yes, you can. Square root of 12 is, in reality, 4 times 3, so I can actually break this one down again. Square root of 4 is really 2, so when I actually take it out of my roots, I'm going to be taking 6 times 2, which is going to give me 12 square root of 3. So be sure you always, when you get done working with roots, you ask yourself, have I simplified it? Okay, the last thing under multiplication, you guys are going to be super excited to see this. Some of you have already told me how much you love to do this back in Algebra 1. So we'll see who can first spot what do we need to do to work this problem. Notice I'm giving you a quantity this time. You have 3 plus 4 times the square root of 5 times 5 minus 2 times the square root of 5. How do I multiply a set of 2 terms times 2 terms? And yes, I know I'm hearing it out there. Our favorite option for those Algebra 1 days, yes, you get to FOIL it. Now, no moans and groans. Shouldn't hear any moans and groans happening here. But, yeah, we get to FOIL it. And just to remind you what FOIL stood for, the F is what? Yes, it's first. The O is outer. The I stands for inner. And the L is, of course, last. It's telling you what terms to multiply. So the F of first is saying you should multiply the first term in each parenthesis. So in this case, that means I'm taking the 3 times the 5, the first term in each parenthesis. And of course, 3 times 5 is really 15. Okay, now, outer, what does that mean? Well, the outer terms are the terms on the outside edges. So if you're doing the outer terms, you're going to take the 3 times the outside one at the back here, negative 2 square root of 5. When you multiply, that 3 is not in a root. So since it's not inside the root, you take it times the 2 in front. You're taking the 3 times the 2 and getting negative 6. You do not change the inside of that root. It stays square root of 5. Okay. Inners are just the opposite then. I need to multiply the 2 terms that are the closest to the middle, which is 4 square root of 5 and 5. Once again, that 5 back here in the second parenthesis is not in a root, so I'm going to take the 4 times the 5 and get a positive 20 times the square root of 5 still sitting there. And then last but not least, where it gets really exciting, the last which means do the last term in each parenthesis. And you'll notice we actually do have double multiplication here. We're going to take the 4 times the negative 2 and get negative 8. But we're also going to take square root of 5 times square root of 5. Okay, right now, I'm going to go with, hey, that's square root of 25. But I'm actually wanting you to discover a little bit of a shortcut for that here as we move through this. You're not done yet. You can simplify these 4 terms that you now have. In particular, I want you to notice, what can you do with square root of 25? Back there on the end. Well, square root of 25 is actually 5. So what I really have there is 8 times 5, or minus 40 out of that deal. Now you have a 15 up front that has no square root on it, a negative 40 in the back that has no square root on it. You actually need to combine those terms. So 15 minus 40 is really going to give us a negative 25. Then you also want to combine the 2 terms that have square roots of 5 on them. The negative 6 square root of 5 plus 20 square root of 5 is going to add up to be 14 square roots of 5. And there you have it. You have FOILed those 2 together, and you have found your solution. Negative 25 plus 14 times the square root of 5. Now, if you really don't like FOIL all that much, let me point out to you what you just did when you FOILed this thing. When you took the first times each other, you actually took 3 and took it times 5. When you did outers, you took the first term times the last term. In reality, all you did there is you just distributed 3 times both terms. When you did the inners and the last, you took 4 square root of 5 times the first term, you took it times the second term. All you're doing is distributing 4 square root of 5 times both terms. So in reality, when we FOIL, we're just doing the distributive property. You distribute the first term times both of them, you take the second term times both of them. So whichever way you prefer to think about it. If you like to think of it in terms of FOIL, or you want to think of it as just distributing, either way works. You're doing the same thing. All right, so there's multiplication. Now we'll move on to what's probably the biggest pain of square roots, and that would be division. And I will quite frankly, I'm going to apologize to you all right now. There's parts of this that I have to teach you because we haven't moved up in the modern world yet, except that we have technology, and some of the rules that we used to follow back before we had calculators that could handle all these lovely functions, we had some rules that are now obsolete. But unfortunately, the textbook writers and the college professors haven't changed yet, so I still have to teach you some skills that, quite frankly, are a little outdated. So my apologies, but until the rest of the world changes, we're trapped and we got to go with them. So parts of this are very useful, parts of this are a little outdated. However, let's start easy and quick. If I ask you to take the square root of 21 divided by the square root of 7, you're going to get, anybody want to take a guess? Well, you'd be right. If you can multiply 2 square roots together, you can divide 2 square roots. So 21 divided by 7 is really just square root. Perfectly legal. You are allowed to divide square roots. Okay, that's not our problem. Sometimes, though, we get a fraction inside the square root. If you are asked to simplify something like that, treat the top and bottom separately. What's the square root of 36? It's 6. What's the square root of 25? It's 5. You're done. Just treat them as separate numbers. Now, when it gets exciting is when you get something like this. Where if you get square root of 20 over 81? Once again, treat them separately. It's like you have the square root of 20 over the square root of 81. Well, okay, square root of 81 is perfect. We know square root of 81 is 9. Square root of 20 is not. So you still need to break it down like we've just been doing in our previous problem. 20 is really 4 times 5. So if I take the square root of 4 out, I have 2 times the square root of 5, all of 9. And there would be my simplified result. Okay, here's the part where it's a little bit obsolete anymore. Back in the days prior to calculators, mathematicians said, we don't really want square roots in the denominator of a fraction, because if you're actually adding fractions together, who wants to make a common denominator with a square root? So they said, we're going to get rid of the square roots, we're not going to let square roots be in the denominator. So they had to find a way to do it. This process is known as rationalizing the denominator. And I'm probably going to say that to you quite a few times in the next few months. You need to rationalize your denominator. What that means is you need to get the square root off the bottom of your denominator. So to do that, we simply go, well, okay, they discovered if you take the denominator, the square root of 7, times itself, you'll get square root of 49. And that will become a number you can break down. But you can't just multiply the denominator times something. We know that with fractions, and when we make common denominators, if you multiply the bottom by square root of 7, you've got to multiply the top by square root of 7. So that we're actually doing square root of 7 over itself, which is 1. So I'm actually going to end up with 5 times the square root of 7. And now I can simplify the square root of 49, and I'm left with 5 times the square root of 7 over 7. Not terrible, but a bit of a pain. You'll get used to it because we do it pretty frequently. A second example of that is what happens if you have something like the square root of 3 halves. Once again, think of it as two separate square roots over each other. Neither one will simplify right now. I'm not allowed to have square root of 2 in the denominator. If I want to get rid of it, I simply multiply it by another square root of 2, because that makes me get a perfect square number. When I take it times itself, I'll get 4, which is a perfect square number, and will break down to be 2 in the denominator. But if I multiply the bottom times square root of 2, I got to multiply the top times square root of 2, which is going to give me square root of 6. And so I'm actually going to end up with square root of 6 all over 2. Rationalizing the denominator is simply getting rid of the root in the denominator so that you have an easy number on the bottom with which to make a common denominator if you needed to. Okay, at this point we're going to do another quick pause, and then we will wrap it up. We've got about 2 or 3 problems left to go here. And so we'll go to part 3. Hang on just a moment.